Everyone, and welcome to the video lecture for Unit 3, Module 7.2. In this one, we're going to discuss the larynx and the trachea. As always, here you can find your learning objectives. So let's go ahead and jump into this one. Inhaled air leaves the pharynx and enters the larynx through a narrow opening of the glottis. The glottis is the vocal apparatus, or the voice box of the larynx. The larynx is a cartilaginous tube that surrounds and protects the glottis. The larynx begins at the level of vertebrae C4 or C5, and ends at the level of vertebra C6. Essentially, a cylinder, the larynx has incomplete cartilaginous walls that are stabilized by ligaments and skeletal muscles. Three large unpaired cartilages form the larynx. One, the thyroid cartilage, two, the cricoid cartilage, and three, the epiglottis. The thyroid cartilage is the largest laryngeal cartilage. Made of hyaline cartilage, it forms most of the anterior and lateral walls of the larynx. In this section, the cartilage is U-shaped, and posteriorly, it is incomplete. You can see and easily feel the prominent anterior surface of the thyroid cartilage, called the laryngeal prominence or the Adam's apple. The inferior surface articulates with the cricoid cartilage. The superior surface has ligamentous attachments to the hyoid bone and to the epiglottis and smaller laryngeal cartilages. The thyroid cartilage sits superior to the cricoid cartilage, another hyaline cartilage. The posterior portion of the cricoid is greatly expanded, providing support in the absence of the thyroid cartilage. The cricoid and thyroid cartilages protect the glottis and the entrance to the trachea. Their broad surfaces protect sites for attachment of important laryngeal muscles and ligaments. Ligaments attach to the inferior surface of the cricoid cartilage to the first tracheal cartilage. The superior surface of the cricoid cartilage articulates with the small paired arytenoid cartilages. The shoehorn-shaped epiglottis projects superior to the glottis and forms a lid over it. The epiglottis is composed of elastic cartilage. It has a ligamentous attachments to the anterior and superior bordage of the thyroid cartilage and the hyoid bone. During swallowing, the larynx is elevated and the epiglottis folds back over the glottis, preventing both liquids and solid food from entering the respiratory tract. The larynx also contains three pairs of smaller hyaline cartilages. The arytenoid cartilages articulate with the superior border of the enlarged portion of the cricoid cartilage. The corniculate cartilages articulate with the arytenoid cartilages. The corniculate and arytenoid cartilages function in the opening and closing of the glottis and the production of sound. And three, the elongated, curving, cuneiform cartilages lie within folds of tissues that extend between the lateral surfaces of each of the arytenoid cartilage and the epiglottis. Ligaments bind together the various laryngeal cartilages. Additional ligaments attach to the thyroid cartilage to the hyoid bone and the cricoid cartilage to the trachea. The median cricothyroid ligament attaches the thyroid cartilage to the cricoid cartilage. Because it has easily identifiable landmarks and is clear of the thyroid gland, this ligament is a common placement site for emergency tracheostomies, a tracheal incision to bypass the airway obstruction. The vestibular ligaments and the vocal ligaments extend between the thyroid cartilage and the arytenoid cartilages. The vestibular and vocal ligaments are covered by folds of laryngeal epithelium. The vestibular ligaments lie within the superior pairs of folds, known as the vestibular folds. These folds are fairly inelastic and lie laterally to the glottis. The glottis is made up of the vocal folds and the space between them, called the rima glottis. The vestibular folds prevent foreign objects from entering the open glottis. They also protect the more inferior delicate vocal folds of the glottis. The vocal folds are highly elastic because the vocal ligaments consist of elastic tissue. The vocal folds are involved with the production of sound. For this reason, they are known as the vocal cords. So how do you produce sound? Air passing through your open glottis vibrates its vocal folds and produces sound waves. The pitch of the sound depends on the diameter, length, and tension in your vocal folds. The diameter and length are directly related to the size of your larynx. You control the tension by contracting voluntary muscles that reposition the arytenoid cartilages relative to the thyroid cartilage. When the distance increases, your vocal cords tense and the pitch rises. When the distance decreases, your vocal folds relax and the pitch falls. Children have slender, short vocal folds, so do their voices tend to be more high-pitched. At puberty, the larynx of males enlarges much more than that of females. The vocal cords of an adult male are thicker and longer, and they produce lower tones than those of an adult female. Sound production at the larynx is called phonation. Phonation is one part of speech production. Clear speech also requires articulation, the modification of those sounds by other structures, such as the tongue, the teeth, and the lips, to form words. In a stringed instrument, such as the guitar, The quality of the sound produced does not depend solely on the nature of the vibrating string. Rather, the entire instrument becomes involved as the walls vibrate and the composite sound echoes within the hollow body. Similar amplification and resonance take place within your pharynx, oral cavity, nasal cavity, and paranasal sinuses. The combination gives you the particular and distinctive sound of your voice. That sound changes when you have a sinus infection and your nasal cavity and paranasal sinuses are filled with mucus rather than air. The final production of a distinct word depends further on voluntary movements of your tongue, lips, and cheeks. Infection or inflammation of the larynx is known as laryngitis. It commonly affects the vibrational qualities of the vocal cords. Hoarseness is the most familiar result. Mild cases are temporary and seldom serious. However, bacterial or viral infections of the epiglottis can be very dangerous. The resulting swelling may close the glottis and cause suffocation. This condition, or acute epiglottitis, can develop rapidly after a bacterial infection of the throat. Young children are most likely to be affected by this. The larynx is associated with two sets of muscles. They include 1, the muscles of the neck and the pharynx, which position and stabilize the larynx, and 2, the smaller intrinsic muscles that control tension in the glottofocal folds, or the open and close the glottis. These smaller muscles insert on the thyroid, arytenoid, and craniculate cartilages. The opening and closing of the glottis involves rational movements of the arytenoid cartilages. When you swallow, both sets of muscles work together to prevent food or drink from entering the glottis. Food is crushed and chewed into a pasty mass known as a bolus before being swallowed. Muscles of the neck and pharynx then elevate the larynx, bending the epiglottis over the glottis so that the bolus can glide across the epiglottis rather than falling into the larynx. While this movement is underway, the glottis is closed. Food or liquids that touch the vestibular folds or glottis trigger the coughing reflex. In a cough, the glottis is kept closed while the chest and abdominal muscles contract, compressing the lungs. When the glottis is opened suddenly, a blast of air from the trachea ejects material that blocks the entrance to the glottis. The trachea, or windpipe, is a tough, flexible tube with a diameter of about 2.5 centimeters or so and a length of about 11 centimeters. The trachea begins anterior to vertebra C6 and the ligamentous attachment to the cricoid cartilage. It ends in the mediastinum at the level of vertebra T5, where it branches to form the right and left primary bronchi. The epithelium of the trachea is continuous with that of the larynx. The mucosa of the trachea resembles that of the nasal cavity and nasopharynx. The submucosa, which is a thick layer of connective tissue, surrounds the mucosa. The submucosa contains mucus glands that communicate with the epithelial surfaces through a number of secretory ducts. The trachea contains 15 to 20 tracheal cartilages, which serve to stiffen the tracheal walls and protect the airway. They also prevent it from collapsing or overexpanding as pressures change in the respiratory system. Each tracheal cartilage is C-shaped. The closed portion of the C protects the anterior and lateral surfaces of the trachea. The open portions of the C face posteriorly towards the esophagus. Because these cartilages are not continuous, the posterior tracheal wall can easily distort when you swallow, allowing large masses of food to pass through the esophagus. An elastic ligament and the trachealis muscle, which is a band of smooth muscle, connects the ends of each tracheal cartilage. Contraction of the trachealis muscle reduces the diameter of the trachea. This narrowing increases the tube's resistance to airflow. The normal diameter of the trachea changes from moment to moment, primarily under the control of the sympathetic division of the ANS. Sympathetic stimulation increases the diameter of the trachea and makes it easier to move large volumes of air through the respiratory passageways. The trachea branches within the mediastinum into the right and left primary bronchi. An internal ridge called the cornea separates the two bronchi. Like the trachea, the primary bronchi have C-shaped rings, but the ends of the Cs overlap. The right primary bronchus supplies the right lung, and the left supplies the left lung. The right primary bronchus is larger in diameter than the left and distends towards the lung at a steeper angle. For these reasons, most foreign objects that enter the trachea find their way into the right bronchus rather than the left. Before branching further, each primary bronchus travels to a groove along the medial surface of its lung. This groove, the hilum of the lung, also provides access for entry to the pulmonary vessels, nerves, and lymphatics. The entire array is firmly anchored into a meshwork of dense connective tissue. This complex is the root of the lung. The root attaches to the mediastinum and fixes the position to the major nerves, blood vessels, and lymphatic vessels. The roots of the lungs are anterior to vertebrae T5 to the right and T6 to the left.